So in this final video about binary search trees, we're going to dedicate all our time to exploring the remove function, or the remove method, which allows us to remove a particular key that we specify from a binary search tree. If you remember, in the earlier videos we looked at how to add a key, how to find a key, how to find the minimum, and how to find the maximum. Now this is another function that's usually an operation that's defined with a abstract data type that is the binary search tree. But it's a little more complicated, as you can see here. What we're going to do is we're going to be exploring all the various cases that are possible when you're trying to find a key. There are 5 cases here. The first 4 assume that the key exists in the tree, and so we're going to find it somehow. And the 5th case assumes that the key is not found, and how is the algorithm handling this case. So we looked at the first and second case. The first case was where the root is null, so the tree actually is an empty tree, and we're just passing an empty tree and we're trying to find a certain key in there, so there's nothing, so we're just returned a null pointer. And in the case where the root was the only element or the only node in the tree, and it happened to be holding the key that we were looking for or trying to remove, what's going to happen is that we're going to be given back a tree that is going to be pointing to null, because we've just removed the root, which was the only node. And now we were looking at the third case where we were trying to remove a leaf node. And to remove a leaf node, we said that we had to go through the green step and the blue step. The green step was to step through the tree using these conditions until you actually got to that leaf node which you're looking for. Okay, so you're going to be asking a question always, is your key, you're going to compare it to a particular node, and you're going to start at the root node, and you're going to say, is your key less or greater than the root node? If it's less, then you're going to basically discard everything to the right and just focus on the left hand side, and so you're going to go to the next node. You keep on doing this, and these conditions are actually going to lead you through your tree until you find your leaf. Once you find your leaf, you're going to get to these points, and these conditions, these first 2 conditions, returning which you're trying to compare the root to null, and you're trying to compare your key to the root, and you're saying, is it less or greater than to that particular node? And of course here when we say root, it could be a node itself. As we dig deeper and deeper, we're actually passing it nodes, and since we know that a tree is defined recursively and a node itself could be a tree when looked at as a subtree, then this makes sense using the root as a name here. So we're going to be going through all of these, and we're going to find out. So now we're at the leaf node, and the leaf node happens to be the key that we're looking for. So these conditions will all return false. We're going to come and step into this. Once we step right here, then we know that we found a match. And then we're going to come to this condition and say, is the left child equal to null? And since it's a leaf node, then this is true. So we're going to return the child at the right side, and the child on the right side is also null. So we're basically returning a null pointer. And that null pointer, what is it going to do? It's going to be assigned to whichever function from these ones called it first. And so your other node, the parent node, which called the remove function, and that remove function finally ended up stepping into this, well, this one will have its pointer to that child pointing to null, because we're trying to remove that child. That child happens to be, now we've just found out that this is the key. It contains the key that we're after. So we're going to remove it, we're going to return a null, and it's going to be assigned to that parent's child. So this works in this case. So this is those 3. The 4th is the internal node. This is the most complicated one, and this is basically what we're going to do is it has also green and blue, so we're going to be stepping through the tree until we find our node. And once we find our node, there are 2 cases. If one of the childs of the node is null, then it's just going to be blue that's going to handle it. It's either this condition or that condition. If none of the children is null, and the internal node has both nodes as children, then we're going to be going through this particular algorithm. What it does is it's going to find the minimum in the right subtree, and what it's going to do, it's going to remove this. So we know that this is the key we're trying to remove. So it's going to find the minimum, put the minimum here, and then call remove function, that same function we're dealing with, and remove it from the right subtree. And then you're going to get rid of it, and so you're going to be fine. And this is the 4th case.